Hello, my name is Sony Hansen.
Hi, I'm Luke McCaffrey.
And we invite you today to learn a little bit more about Aero True CT, its clinical benefits, key features, and 4 workflows to be implemented in the OR space.
These 4 workflows will look at thoracolumbar, upper cervical, cranial, and lower lumbar anatomical regions.
We hope to shed light on how Aero's workflow can be incorporated into current, existing, or future workflows within the OR without sacrificing value, but bringing great image quality to the space. Aero True CT is a portable, high-resolution 32-slice CT scanner with an integrated table solution. You'll be able to transfer images within seconds, all from a system that's designed for years to come. Now, part of being a fan beam True CT scanner means we offer both axial and helical imaging acquisition. These custom or standard protocols can help support imaging of both the cranial and the spine space. It's also important to note that this integrated table solution is partnered with Hill-Rom Trumpf. This table solution has 360-degree rotation and can help support versatile setups within the OR and intraoperative space. Additionally, Aero is a portable system, so powered through electrical drive system at the bottom of the gantry, we'll be able to drive as a single user the Aero through standard hallways, doorways, and even standard elevators. Up ramps of 5 degrees, this system can be taken out of the OR that it's typically in and brought mobile throughout the facility. Additionally, Aero is powered through batteries. Everything can be managed from the Aero operator on the side of the pendant. That's where the operator can key in information about the patient, imaging protocols, as well as scan from there. Now, compared to other 3D fluoroscopy imaging modalities you may see in the OR, that means Aero does not have an additional monitor cart. This helps reduce that footprint, again, compared to other imaging modalities. When talking about footprint, Aero has a small footprint of 2 feet by approximately 6.5 feet, including the column in the front. It's important to note that large gantry opening. That bore is 107 centimeters or 42 inches wide. Not only does that physical spec help accommodate larger patients or even arm boards, it has a field of view of 51.2 centimeters. That, coupled with a full meter scan length, gives a huge volume of scan area and scan range. Now, within 40 seconds, we can scan that full meter with helical scanning. Once that scan's complete, we have standard DICOM export, meaning we can send that scan to anywhere that receives the uncompressed DICOMs, such as your navigation system or your PAC system. Aero has 10 main components. The first one to look at is the ring. That white circular piece hosts a number of imaging pieces necessary for scanning. This includes the tube, the detector, PCs, as well as even the batteries. Next to the ring, and on the far side, there's going to be the pendant and pendant holster. This pendant is the handheld command center of the Aero and is where the user will input information when it comes to scanning, selecting protocols, or pulling information from the system. That pendant is attached by a 14-foot cord. Below the pendant, you notice a power panel. That power panel is where the user can key on and off the Aero system. All of that sits on the gimbal. That gimbal is the U shape that's below the ring. The gimbal also hosts a number of important features and elements of the Aero True CT, such as other PCs and powering equipment. Below that gimbal is going to be the base. That base is about 2 feet by 5.5 feet. It has 2 sets of rails, which is where the gimbal and the ring will translate along when scanning. Unlike conventional CT scanners, the Aero will actually have the gimbal run forward and back during the scan, and the patient will stay stationary. Below that base are 4 casters. Those caster wheels will help direct the user when driving the Aero throughout the hallways. The main drive wheel, which is located underneath the gimbal, will power the system when transporting around by a single user. As we move our way to the front of the system, you'll notice the column. This is actually a Hill-Rom Trumpf product and supports the TS7500 surgical tables. On the side of the column, there's a column input or keypad. That's where you can also manually raise or lower the table, trend it, tilt it, etc., extend it forward, but it also comes with a wireless remote, which the same information can be keyed on for the table. Now, lastly, on the other side of the gantry, when transporting the Aero, is a camera. That camera can help direct the user from the pendant when driving to see what's in front from the screen of the pendant. This video is intended to outline 4 suggested workflows that could be implemented in a clinical setting within the OR. However, this video does not replace the Stryker's operator training manual, nor does it replace the training that's provided by Stryker. Always defer back to the Aero operator training manual. Depending on the surgeon, the patient, the case, the room layout, these suggestions may vary for the particular facility and for the particular setup in that room. However, of course, these are 4 optimal suggestions that we are providing today and demonstrating. Let's talk a bit about room setup or preoperative setup with Aero True CT. Park the Aero scanner in the designated room for the case either the night beforehand or the morning of. Be considerate of where the anesthesia cart is typically located for that workflow. Once parked in the appropriate location, the gantry can rotate a full 180 degrees. Depending on which way it's rotated, we can optimize imaging on the lower half of the anatomy. If rotated that 180 degrees, can help optimize imaging on the upper half of the patient. Another way we can leverage gantry rotation is by maximizing room for patient positioning. We can of course rotate that gantry and keep it at an angle such that more staff can gather around the table, perhaps during patient transfer. Now ultimately, once we've decided on a gantry rotation and have parked the Aero, the trained tech will come in and perform the maintenance scans. These need to happen 18 to 24 hours prior to clinical use. These scans will include the warm-up scan, the e-stop, gang-cal, and the QCs. Let's take a look at the thoracolumbar scenario for our Aero workflow. In this circumstance, we're going to start by parking the Aero in the appropriate room for the procedure. When parking it, we want to be making sure the anesthesia in the cart is positioned behind the gantry or behind the bore, and such that the table is in the appropriate location where the operation will occur. Now that the patient is entering the room, they will be received by anesthesia and intubated on the hospital bed, and all appropriate lines can be added. Now that the patient has been intubated on the hospital bed, we're going to disconnect both the tubing and any other wires that are attached to the patient to free them from the anesthesia cart. This will allow the patient to be rolled over next to the carbon spine. As the patient's moved over and the tables are leveled, we can log roll our patient onto the carbon spine that's attached to the Aero. Note that carbon spine has been rotated at around 30 degrees to help open up the room for the log roll. Ultimately, once the patient has been positioned on the carbon spine, rotate that table back in and drive it forward towards anesthesia to reassign the tubing from the anesthesia cart through the bore of the gantry. When the patient is in position, we're actually going to perform a collision check prior to the patient being draped. The rad tech will re-enter the room using either the wireless remote or the column keypad to get the table into the appropriate position necessary for scanning later on during the case. Though we're not scanning right now, this is a great time to ensure that there's going to be no collision between the table and the gantry itself. Once in position, the rad tech can go ahead and save that table position such that it can be used later on during the procedure. Now, prepare and drape the patient for surgery as you standardly would. Additionally, bring the navigation system into the room and put it in the position at which would be preferable for the surgeon or where you typically keep it for your standard surgeries. Once the operation commences, we can of course save the table position as the operational position. Once the exposure is complete, we can go ahead and drape the patient for the scan itself. Once that drape has been assembled, ask all non-essential personnel to please leave the room as we prepare for the Aero scan. Now the rad tech will move the patient into the appropriate location for the scan itself. They can use the saved scan position, which they saved during the collision check early on in the procedure. Once the patient is in the appropriate location, we can start our scan workflow. This may include a 2D scout scan, which will check the field of view, as well as a start and end position for ultimately the 3D spin. That start and end point will be determined by the surgeon and could be chosen over the course of a full meter. Once completed, we can go ahead and take our 3D spin.
Scanning.
Now the table can return back to its original operation position, and essential personnel can return back to the room. In doing so, we can get the Aero and the table in the appropriate location to resume our surgery. Additionally, at this point, we're going to undrape the patient and be able to discard that non-stale drape to the side. As we resume surgery and continue on with the procedure, at any point if another intraoperative scan is needed, we can continue a similar workflow to make sure your intraoperative needs are met. Let's take a look at an upper thoracic cervical Aero workflow utilizing a head clamp and operating at 90 degrees head first. In doing so, we're going to want to park the Aero in the room desired with the gantry at the angle to the anesthesia cart. You'll also note that our gantry is rotated such that the pendant is going to be closest to where the patient's head will be during anesthesia. Now that the patient is being brought into the room, we can anesthetize on the hospital bed, apply the appropriate tubing, cords, lines, etc. as needed. Additionally, we'll also want to add the radiolucent head clamp here. Once that's done, we can log roll onto the carbon spine and fixate from there. Now that we've log rolled the patient onto the carbon spine, we can rotate that table back in line such that the table can be extended into the gantry. This will allow us to perform a collision check. This collision check will also allow us to save that table position on the wireless Hill-Rom Trump remote. Now we'll rotate the table 90 degrees into the operation position. The head will be closer to anesthesia, but be in the position optimal for the surgeon and the room layout. Now ultimately in this position, we can begin draping for the surgery and the incision. We can bring the navigation system into the room in preparation for the scan that will be soon to come. While the surgeon is performing the exposure, we can go ahead and save the table operation position. This will eventually be utilized once we come back from our scan. Now that we've performed the exposure and we're ready to go in for our navigational scan, we're going to go ahead and start prepping and draping the patient for that scan. We will drape over the operation site such that it will be protecting the patient when we go in for an Aero scan. Once that patient's Z-drape has been fixated around the patient, utilizing the remote, we can unlock and slowly rotate that patient into the gantry. To start the scan workflow, we'll take the appropriate radiation safety precautions as well as ask non-essential personnel to please leave the room. That rad tech can either choose to perform a 2D scout scan as well as a 3D CT scan, or in this circumstance, choose to perform just the CT scan. Once we found the appropriate locations for the start and end position, we can go ahead and start the scanning process and emit the radiation.
Scanning.
Now that the scan's complete, we can ask essential personnel to return back to the room. We can rotate our patient back 90 degrees to the original operation position. Feel free to pull off that patient's Z-drape to continue the operation. At this point, Aero scans should have returned over to the navigation system where you can check in those scans and prepare for the next part of the procedure. For additional scans or post-operative confirmation, please repeat the scanning steps. Let's take a look at a lower lumbar sacrum workflow with Aero True CT. In this circumstance, the patient positioning will be such that they are feet first when entering the bore during the scan. The Aero will be parked such that the gantry is going to be opposite of the anesthesia cart. You'll also note, though a suggestion, the gantry is rotated such that the detector is closest to the column. As that patient enters the room, anesthesia can receive the patient in the hospital bed, adding any appropriate tubing, wires, or cords at this point. You'll also note that the carbon spine is angled at 30 degrees. This can help open up the area for staff members or anesthesia during this patient positioning portion. Now that the patient has been anesthetized, staff members can log roll the patient from the hospital bed onto the carbon spine, which is integrated into the Aero. Once the patient is fully positioned and appropriate accessories have been added, you can rotate that patient in such that they are perpendicular to the gantry and ready for the collision check. The Aero-trained tech can enter the room and raise the table or extend it to perform the collision check. Since the patient is not yet draped, this can provide better visualization to ensure that none of the accessories may potentially collide with the gantry. Additionally, this process can help determine whether or not the scan range will be able to meet the operation or scanning needs given the lower lumbar or sacrum region of interest. In doing so, the rad tech can also use the wireless remote to save that scan position such that it can be utilized later on during the procedure. Once this collision check has been performed, the table can be returned back to the operation position. Now, we can begin by preparing and draping the patient for surgery. At this point, if desired, the navigation cart can be brought into the approximate location that will be utilized for surgery. Of course, this could be dependent on the surgeon preference as well as the room layout. After performing the exposure and preparing any necessary navigational accessories, save the table operation position using the wireless remote. Once saved, we can begin by prepping and draping the patient for the navigational scan. Here we're using a patient Z-drape to cover the operation site. This will allow that operation site to be protected when the table translates into the bore during the scan itself. Utilizing that wireless remote, the trained Aero tech can bring the table to the scan position as saved earlier on during the collision check. Once the table has been brought into the appropriate position, non-essential personnel can be asked to leave the room. Taking the necessary radiation safety precautions, the Aero trained tech will begin the 3D scan workflow. This 3D workflow can incorporate a 2D scout scan, which can help determine the start and end location, as well as determine the field of view. Once set, and the imaging protocols have been keyed in on the pendant, the rad tech or Aero tech can initiate the scanning process.
Scanning.
Return the Aero and table back to the operation position to resume surgery, and ask non-essential personnel to return back to the room. The trained Aero tech will use the wireless remote and return the table back to the operation position, which was saved earlier on during the procedure. Now, the staff members can remove the patient's Z-drape to expose the operation site and resume surgery. Here, the surgeon can check navigational accuracy as the Aero scan would have come over onto the navigational cart. For additional scans or post-operative confirmation scans, please repeat the scanning steps. Let's take a look at a cranial workflow utilizing an U24 HVA neuro table with Aero True CT. Let's start preparing for our case by parking the Aero in a position such that the gantry is going to be opposite of the anesthesia cart. You'll also note that the pendant is on the same side as where the patient's head will be. Once anesthesia receives the patient on the hospital bed, and depending on the surgery, the patient could be intubated on the hospital bed. Any additional wires or cords can be added here as well. Lastly, the radiolucent head clamp can be attached on the hospital bed prior to the patient being slid over onto the U24 table attached to the Aero. You'll note that that table is at an angle to help open up the space for the staff members. Once the patient has been slid onto the U24 neuro table, take the time to connect the radiolucent head clamp to the adapter that's connected to the table. Rotate the table using the wireless remote. The gantry can also be rotated to ensure a larger radius of clearance when rotating that patient in. The rad tech or Aero tech can go ahead and perform a collision check. This collision check will ensure that no other table adapters or accessories may potentially collide into the gantry when changing the table position from operation to scan position. Now, the Aero tech, using the wireless remote, can store that saved position. Now we can prepare for a 3D workflow and non-essential personnel can leave the room. Taking the appropriate radiation safety precautions, the Aero tech can now initiate the intraoperative scan workflow. This workflow can include both a 2D scout scan as well as the final 3D CT scan. That 2D scout can help set the start and end positions as well as adjust the field of view. Here we're just opting to do the 3D CT scan. That will also set the start and end positions, which can be determined by the surgeon. Once those have been set, the Aero tech can use the pendant to select the appropriate imaging protocols. Once selected, we're ready to take our 3D CT scan.
Scanning.
Now that the scan's complete, return the Aero and the table back to the surgical position. Utilizing the wireless remote, you can store and save the final operation position. You'll also note at this point, the gantry will translate backwards towards the column. This will open up the operative site. Now that essential personnel have returned to the room, we can continue prepping and draping the patient for surgery. Note, for any additional follow-up or post-operative confirmation scans, please repeat the scanning steps.
Hi, this is Luke McCaffrey, and I'm an Associate Product Manager with the Aero True CT. Today we're going to be going through the maintenance scans that should be completed on the system every 18 hours. The first is the warm-up scan, the second, E-stop scan, the third, gain calibration, and the final are QC scans. The warm-up scan is a low-powered scan that must be run 24 hours since a previous scan in order to protect the system from running a full-powered scan on a cold tube. The E-stop test is used to confirm the functionality of the emergency stop button. Once pressed, the functionality of both the gantry, tabletop, and X-ray radiation will be halted. In order to reset the system and regain functionality, you need to press the reset button. The gain calibration is an air scan used to calibrate the system to the room condition and detector condition. When performing this, you must ensure that there's nothing in the ring. The QC scans are run in both helical and axial image acquisition techniques and are used to measure and confirm image quality of the system. They utilize a Gamex Phantom, which must be lined up perfectly utilizing the lasers in the center of the ring on the system. When lining up the Phantom to the lasers, the first step is adjusting the rotation of the Phantom itself and the table height. First we go and line up the rotation so that the error between the laser and the white line is the same on either side. Once that's ready, next is the table height. After we have the table height correct, we come to the back side and use the knob to adjust the tilt of the Phantom. We know that's good when the lines are perfectly across on either side. The next step is lining up the top line perfectly with the lasers as well. That you adjust the base with. Finally, we have to line up the last laser with the first module on the Phantom on the foot side, and for that we use the buttons on the pendant. Once it's all lined up, you're ready to take the QC scan.